Hi everyone, my name is Christina. I'm a first year PhD at the Visualization Research Center at University of Stuttgart, and today I will speak about machine learning for automatic visualization design. So my research is generally somewhere at the intersection between machine learning and visualization. And generally, when people combine these two concepts, you imagine this type of research where you do beautiful visualization of surface loss, or you inspect activations in neural networks, or more generally, anything connected to interpretability. And in many ways, visualization is one of the pillars for interpretability and in machine learning. But myself, I'm more thinking about how can we use machine learning to improve visualization design. So rather than visualization helping machine learning to achieve interpretability, machine learning helping visualization. So generally, people are very good at getting information fast from visualization. They will infer trends when they look at the line chart. They can spot real data in lines of fakes. I'm sure everybody has their own experiences with information visualization. However, people also jump widely to conclusions and are hopelessly bad at the kind of statistical thinking required for good decisions. And there's so many irrational biases and interference effects. So in many ways, good visualization aims to find the best design parameters that minimize human perceptual biases. So in a general visualization process, somebody proposes an improved version of a design. So here we have the basic scatter plot and a sunspot plot. And how do we evaluate whether a new design is actually better? We get some users, we split them into groups, we ask them to perform a task on this visualization, and then we compare which visualization better supported this goal. And these findings usually generalize well across the user pool, but for practical reasons, the datasets tested are limited to few examples. And what we were thinking was, wouldn't it be cool if we just trained the model to replace the person in this evaluation system, and then we evaluate a massive amount of data using the trained model. So we don't have to pay as many users in our user studies. And then potentially with this trained model, we can also evaluate future design proposals. So what did we do? We started by running a study where we asked people how different are the people in these countries from the rest. So for example, how different are the people from in India from the Americans in Italy? And this was kind of a proxy to collect perception data of class separability. And we trained the model to do this with 95% accuracy, which was great. And then we said, why stop here? So we started thinking about using this model to optimize scatter plot design. So in this example, we think about the raw data as the ground truth and the visualization. So the scatter plot is having to align with this data. So what we do is we get the separability estimate from the real data, the raw data, and one from the scatter plot. And these two estimates kind of have to align. And we can make them align by optimizing these following parameters. So the sample points used for the plot. So even if you don't sample, if you have overplotting, only some points will be visible to the users, and the model estimate should just be on the visible points. Then you have things like axis ratio, marker size, marker type, plotting order of points, things like that. And what we found out is that like some data is obviously perceptually robust. So here you have 4 scatter plots design made from the same data with different point sampling and different marker size. But actually it doesn't matter because all these classes are separable from each other when you look at them. So the design does not influence that much. However, in other examples, uh, the data is more ambiguous. So in these 4 scatter plots, you again have different sample points and different marker sizes. However, in some of them, there's more perceived separability, and in some of them, there's less perceived separability, even though the data is the same. And we want to optimize, to create optimal scatter plot here. And then we thought, oh, this idea kind of works. Let's try it in a different scenario. and I present you Dumbledore, named after a Harry Potter character, which should just provide additional intel into my personality. What we were thinking was that when people apply dimensionality reduction to their data, they use it kind of in a black box way. So essentially, they just run their Jupyter notebook multiple times and they create all this data, and then they look at the projections and select one. And I was actually a data scientist before becoming a PhD. And in this consultancy where I was working on, this is exactly what we were doing. We were selecting one, and that was going on the slides for the client. So we wanted to find out what people look after when they apply dimensionality reduction as an exploration task, and if people agree with each other when they do this. And if they do, we would like to build a recommendation system for dimensionality reduction projections. So we avoid this manual grid search for the best projection ever. So how did we do this? We again ran a user study. And in this particular one, people had to distribute 15 points across 8 projections for the same data. And in this process, they would create a weekly ordered list of these projections, like ranking projections from most liked to least liked. And in step 2, we took each projection and we calculate some quality metrics based on them. So these quality metrics are trustworthiness, stress, but they can also be checking if there's a manifold in the projection or if the classes are separable, and also just scatter plot metrics like are there outliers here, are there clusters, to kind of check for all kinds of tasks people might be interested in. And the idea is to sort of learn the connection between these metrics and human preferences. This is, of course, subject to people actually being consistent with each other. Another thing we were interested in is to study whether the general population has the same opinions as experts. And the reason I'm mentioning this is because the study is actually running as we speak, and you could be the perfect expert user if you have nothing better to do. Previous user said it was fun, so I will just link this study in the description. And yeah. So the challenges with this type of work are generally the study design. It is very, very difficult to collect reliable perception data for user because perception isn't perfect, and you would like to get as accurate data as possible. So the wrong study design leads to useless data. If you pose the question wrong, many people will be confused, or you might overspecify the data, in which case it's also not really useful because very well specified tasks we can already measure with statistics. And the other issue I currently have is training deep learning models like CNN on graphical perception data. So this is very tricky because the failures and successes of such models are not necessarily in line with failures and successes of human ability. So imagine you have a person and you try to, then the task is assess how many points you have in the scatter plot. And people are usually good at giving fair estimates up until 1,000 points per visualization. But if you actually manage to train a deep learning network that does that, it will be consistently good with like millions of points when the person would break at 1,000. And conversely, you have tasks, perceptual tasks, where humans are very good and deep learning networks are bad. So this mismatch is really problematic, and you have to be very, very careful to train these types of models. So for these reasons, in the future, I'm trying to depart from these types of supervised models and learning from humans, perceptual annotations. And I will try to explore the design space of visualization using self-supervised methodology or contrastive learning, where data augmentation is replaced by parameter and design variations like marker size or color in scatter plots. Anyway, this is all from me. And if you're interested in finding out more, I will wait for you in the Q&A session. Thank you.